Dear Professor Dr. Seiya Professor in Honor and Doctor of Science Topological Graph Theory Math Education Yokohama National University Japan Seiya born in 1957 He was graduated in Tokyo Institute of Technology He was Dean of Faculty of Environment and Information Sciences from 2014 to 2018 and working as Executive Director and Vice President for Education and Publicity from 2019 to 2020 in Yokohama National University. He is a mathematician which is a pioneer of topological graph theory in Japan and working for reformation of mathematics education research field topological graph theory graph covering applications graph coverings are a fundamental concept in graph theory with various applications in computer science network design and other fields Here are some key points about graph coverings and their applications definition A graph covering is a mapping from one graph called the base graph to another graph called the covering graph in a way that preserves certain structural properties. The goal is to find a covering that satisfies specific criteria or constraints applications network design, coding theory topology and geometry parallel computing cryptography types of coverings regular coverings Galois coverings algorithmic approaches In summary graph coverings are a versatile concept in graph theory with applications spanning multiple domains including network design, coding theory topology parallel computing and cryptography. They offer insights into the structure and connectivity of graphs making them a valuable tool for solving practical problems. Artificial intelligence AI plays a crucial role in optimizing data for various applications including instrumentation physics, food security and energy sustainability. Here's how I can contribute to data optimization in each of these fields. 1. Instrumentation physics data analysis signal processing automation. 2. Food security crop monitoring supply chain optimization predictive analytics. 3. Energy sustainability smart grids energy management renewable energy handling big data automation prediction and optimization. Overall AI is a powerful tool for data optimization and instrumentation physics, food security and energy sustainability enabling more informed and efficient decision making in these critical areas. The statement you provided if a connected graph G has a finite planar covering then she has a twofold planar covering is not generally true. In other words, it's not a valid statement. In graph theory a finite planar covering and a twofold planar covering are not equivalent concepts and the existence of one does not necessarily imply the existence of the other. A finite planar covering typically means that you can cover the vertices and edges of the graph with a finite number of planar graphs without specifying how many times each edge is covered. A twofold planar covering would imply that each edge of the graph is covered exactly twice, which is a stricter requirement than a finite planar covering. It's possible for a connected graph to have a finite planar covering without having a twofold planar covering, and it's also possible for a connected graph to have a twofold planar covering without having a finite planar covering.